Hello, and welcome to this demonstration where we're going to be taking a look at how you can use columnar storage with the MariaDB Python connector combined with a couple of other tools so you can get a look at what it's like to use modern data science utilities to check out real-time analytics. So let's go ahead and get started. And we're going to start by taking a look first at columnar storage. Some of you out there may already know what that is, or maybe you just need a refresher, but we're going to go ahead and get everybody running at the same pace and on the same page so that when we jump into the demonstration, we'll know exactly what we're dealing with. So on the left-hand side here, take a look, we've got row-based storage. And likely most of you out there are already familiar with it. This is your traditional relational database storage, and everything is really stored in rows, or ultimately tables within a file, or most likely multiple files on the actual physical disk. On the right-hand side, you have column-based storage. And what that means is pretty self-explanatory, is that you're taking what would have traditionally been stored in tables, and you're actually splitting up the columns to store those all together within a file, or most likely multiple files. And there's a couple of advantages for this, right? So as we go ahead and take a look at maybe one of the simplest ones, the benefits are really easy to see right from the beginning. On the left-hand side here, if we want to run an aggregation query, so your kind of typical analytics or analysis query on, a large amount of data, but in this case, potentially a billion rows, we can see that we're having to do an entire table scan, right? So we're looking at every single row in order to be able to get an average on just one individual column. And in this case, if we've taken a hypothetical situation that this row is 200 bytes, well, times a billion equals about 200 gigs of disk I/O. So pretty large amount of disk I/O used there. Well, on the other hand, right, on the right-hand side, for a column-based approach, because you're just using an individual column, again, because that information is stored down at the file level or the disk level per column in those files, we're able to just target those column values or that column data for our query. And so if we can imagine that a column itself is only 4 bytes times that billion records, then we're really only using 4 gigs of disk I/O. But that's really only the tip of the iceberg here. Well, there's a lot of reasons why you would want to use columnar storage, and we've seen it in the past and throughout the years that it's heavily used within data warehousing, right? Being able to store large amounts of historical or analytical data, maybe historical data dating back years and years and years. But either way, it's just a large amount of information. And then as you start to dive deeper into that, there's several different advantages to being able to store things in a columnar format, such as the ability to compress things very easily, right? So again, kind of harkening back to the previous slide, we know that if we're storing something of a similar type, then we can much more easily be able to compress it. So we see very high compression ratings. Now, beyond that, we're starting to dive into more vendor-specific functionality or capabilities that exist within columnar storage. And I'm going to be taking a look today, especially within the demonstration, at MariaDB's columnar format ColumnStore. So it's a particular engine that we can store column-oriented data and then be able to query against that in real time. And that's ultimately a really big benefit to using ColumnStore within MariaDB is the ability to do some kind of real-time, or what we could think of as operational analysis on a large amount of data. And then diving a little bit deeper, you get some of the benefits of being able to handle null values or sparse data extremely well. It's great with a large amount of columns. And if you wanted to dive even deeper into the architecture of MariaDB ColumnStore, then you could certainly go out to MariaDB.com and find more information where it utilizes things like distributed storage and processing, and even being able to do things in a highly concurrent fashion in order to get a lot of parallel processing whenever you're using distributed columnar data. And all of that you can find on MariaDB.com. But we're really going to be looking at a more pragmatic view and really highlighting in particular this last point, which is that we don't have to add any performance enhancing indexes in order to be able to dynamically create our queries and be able to gather this information in real time on a large amount of data. Now, I've already alluded to it a little bit, but if you're not familiar with the MariaDB ecosystem, then you may not necessarily know that it uses pluggable storage engines. And this idea of pluggable storage engine comes into play for handling different types of data workloads, right? So if you look at these pluggable storage engines, each one of these can be used or not used within the database system itself. And it allows you to be able to handle different types of workloads, as I said. So looking over on the left-hand side, you can look at NODB, which is more of your mixed or traditional relational workload where you're balancing your reads and your writes. Where maybe if you've got an IoT application, you may use something like MyRox, which allows you to have more write intensive or really just writing to the database more often, much more often really than you're reading from it. You have the ability to use distributed SQL or a more scalable option and expand. And one thing that we're going to be looking at specifically today, of course, is ColumnStore. So we're going to exclusively take a look at the ColumnStore engine as it exists in MariaDB and how you can use columnar format or columnar storage in order to be able to, run dynamic or ad hoc queries without having to add performance enhancing indexes. And that's all I have for the slides. We're really just going to jump into the demonstration here. And the demonstration is going to be using MariaDB SkySQL. So if you're not familiar, MariaDB SkySQL is MariaDB's very own kind of home-baked database as a service. And a database as a service is just essentially a database in the cloud that's managed for you. And MariaDB offers SkySQL, and that's what I'm going to be using for the demonstration today. But the real takeaway here is that we're going to be using MariaDB SkySQL or MariaDB in the cloud simply as a database that was easy for me to spin up and load data into. You could certainly be able to use this on-prem through a container of some sort, but we're going to be using MariaDB SkySQL, and we're going to be using it with a couple of tools. So on the left-hand side here, you can see that I've got tools like Jupyter, Plotly, Pandas, and MariaDB Connector Python, all of which I'm going to jump into a little bit more elaboration, description of what those are. But ultimately, what we're going to be trying to do is show how we can connect to and ultimately communicate with MariaDB SkySQL to execute queries in real time on a large amount of data without having to add any kind of indexes, and then ultimately be able to visualize that in some kind of format that we're used to or something that's a little bit easier on the eyes and easier to consume. So with that said, we're going to go ahead and jump into our demonstration. I'm going to slide over screens here, and it's going to jump me directly into what is called Visual Studio Code. This is simply an integrated development environment or IDE, and I'm simply using it basically to just show off the project structure that I have here. Everything that I'm going to be showing off today from a demonstration perspective has been added to GitHub. It's completely free, completely open source, and it's something that you're able and capable to be able to do and get started with right after this demonstration within a matter of minutes. And the first part of this demonstration, I want to highlight the actual schema, the tables, and the data that I've already added to my MariaDB database instance. And this is important because this is going to allow us then to be able to write the queries and execute things on real time without those indexes so that we can see the benefits of being able to use columnar storage inside of our data science utilities, right? So first things first, I have this schema.sql file, and its job really is to create the schema, which makes sense. And then inside of there, we have the database of travel. So we're creating a new database, and it just contains 3 tables. The 3 tables are airlines, airports, and flights. And this is to basically position an application that we can start to look at domestic travel information within the United States. So if we look at the different tables, we can see that, one, I've got them collapsed, but if I open them up, each one of them, of course, contain at least a few columns that define things like the airline, for instance, for the airlines table, particular codes that are specific to the airline industry. But what we want to key in on is the fact that I've set the engine. Now, the engine is where we're specifying, again, those pluggable storage engines. And I could have used NODB or MyRox. And in this case, I'm specifying that I want to use the ColumnStore engine, which of course stores things in a columnar format. So everything stored within all 3 of these tables, ultimately on disk, is stored in a columnar format. Now, the airlines and airports tables aren't necessarily that interesting. They just contain the airlines and the airports for the United States, right? So they're all the domestic airlines and airports. There's about 30 airlines and about 350 airports scattered throughout the United States. What we really want to key in on is this flights table. This flights table, it has data loaded directly from the Bureau of Transportation, and it's about 40 million records. So not a massive data set, but enough to give us a taste of what it looks like to be able to use a pretty large data set or a decently sized data set with MariaDB ColumnStore. So inside of the flights table, we have all kinds of information, right? We've got the date of the flight, we've got the carrier that was used, we've got specific information about the airplane, and then actually, whether it took off on time, whether it was delayed, things that we can jump into and certainly analyze more, and then hopefully be able to visualize using some of our tools. And of course, if I collapse it back, we can see that it also uses the ColumnStore engine to allow us to be able to key in on that column or storage format and use that for the 40 million records of flight data. So, okay, so seeing is believing. So what we want to do next is that we actually want to use the MariaDB command line client to go ahead and jump into or connect to SkySQL, again, that database in the cloud, and take a look at the data that I've already loaded. So as I mentioned here, this is part of a repository, which I looked really at the schema.sql file. But in the rest of this repository, which you can certainly gain access to and take a look for yourself, it gives you instructions on how to actually load all of this data into the database as well. But it takes a couple of minutes to download and then be able to import that into the database. So I've already done that for us so that we can just jump in and start using it. All right, so if I go ahead and load a terminal window here, I'm going to go ahead and minimize some things so that we can just take a look at this terminal window. What I want to do is I want to connect to MariaDB SkySQL, and I'm going to do that using a client on my machine just called the MariaDB command line client. Now, you could certainly use any number of different clients that you use in order to be able to connect to different relational database systems and then execute the SQL that way. But this is a very simple approach to keep it all in one window and basically to just make it super easy to kind of read through what we're going to be doing here. Now, I'm going to go ahead and I'm going to paste in the command and then I'll execute to be able to connect. But that way I don't fat finger any of the stuff that I'm putting in here, and we can just kind of walk through what's happening. Well, as I mentioned before, we're keying into the MariaDB command line client, and that's going to allow us then to add some information like the host address, which is where in SkySQL we have our database that lives inside the cloud. And then the port number in combination with the host address really gives us that location that we can access it. I've got things like the username and password that allow us to provide credentials through the command line client. And then I'm using a certificate file on my client machine, which is just further security measures to tell the server that I, as the client, have access to MariaDB SkySQL. So once I do that, I'll just press enter in order to be able to connect to. And then you can see here that I have loaded MariaDB, and that allows me actually to now start querying as I'm connected to MariaDB SkySQL. So I'm going to go ahead and just do show databases as a command. And what that's going to allow me to see is that I've already created the travel database here. So once I've done that, I'm just going to execute a couple of commands. So I'm going to step into travel. And I want to show the tables. So I executed the show tables command, and I can see that I've got the airlines, the airports, and the flights table. Now, before I get started executing anything on flights, I also want to know whether I have any indexes, right? Because you want to know I haven't cheated and added any indexes that are going to make the performance better. So first things first is I'm going to first count the number of records so that we can see the number of records inside of the flights table. And here we can see that it's about 38 million, a little bit over 38 million records, almost 40 million records. Now, it came back pretty quickly, right? In about a third of a second. So let's go ahead and check to make sure that I haven't added any indexes. So I'm just going to say show indexes from flights. And not very interesting, but we can see that I have an empty set, right? I don't have anything in here for an index perspective. But yet I'm still able to, let's say I want to do an average on a column called departure delay. And departure delay basically just lets you know in how many minutes it took, as a delay in order for that flight to take off. So I can do that from flights, and we can see that still under a second, right? About 0.7, 0.8 seconds, that I've seen that over the course of time, all the way back to 1987 until now, we have about a 9-minute, a little under 9-minute delay average across all the airlines, across all the airports. And we can get a little bit more specific and say, okay, well, specifically for the year, maybe 2019, what were we looking at? Well, it's a little bit larger than the holistic average, but we can see that it's about 11 minutes delay. And this is interesting, right? But not that interesting because, again, we're just kind of writing some terminal code. And so what we really want to do is it would be more interesting if we could actually step into a tool to allow us to both visualize, right, or both analyze and visualize that data all in real time, which could really be cool and allow us to be able to do this using columnar format, again, without having to add any indexes. So to do that, I'm actually going to, let's do a ls here, make sure I'm in the right spot. I've created a project, and I've created just a little bit of it, and what it's going to allow us to do is it's going to allow us to use something called Jupyter Notebook, and more specifically Jupyter Lab, which is a web-based notebook application, which is going to allow me to run ad hocly some Python that's going to let me do things like analyze the data and visualize the data that exists in SkySQL. But in order to do that, I've gone ahead and pre-installed Jupyter Labs, and I've gone ahead and installed an extension to allow us to use some of the tools that we're going to use, only because it takes a couple of minutes to do so, and you certainly don't want me to fill the time with bad Python jokes, which I could do if I needed to, but I'm not gonna do that to you now. So what I first want to do is I want to step into what is called a virtual environment for Python. And if you're not familiar with a virtual environment, basically what that is just a self-contained ecosystem that lets us like freshly add the dependencies or the packages that we want to without having everything else that's on our local machine. So I'm going to activate that, and I've stepped into that actual virtual environment. Now, from here, what I want to do is I want to do pip list, which is just going to show us the packages that we've installed for Python. Several of them, but they've all been installed for Jupyter Lab. So what we don't have and what we're going to be using is a couple other packages to allow us to connect to SkySQL, bring that data down, and then visualize that with a couple of tools. So the first thing we're going to do is we're going to install MariaDB, which is the package, the connector or the driver, which is going to allow us to connect to MariaDB SkySQL. Then I want to install Pandas, and Pandas is going to allow me to take the data from MariaDB cursor inside of the Python connector, so from the MariaDB driver, put it into Pandas into something called a data frame. And then that data frame I'm going to use to actually fill or create a chart or a graph inside of a visualization library called Plotly. So I'm going to go ahead and execute this. And what this is going to do is it's going to start to install these packages. Now, once I've installed the packages, I'm going to run a command called Jupyter Space Lab. And in Jupyter Space Lab, what I'm going to do there is it's going to actually, once I execute that command, it's going to start up my browser window. So it's going to automatically start up a browser window, and it's going to let me start creating notes within a notebook, or cells of Python code that I can use in order to be able to visualize and essentially analyze and visualize the data using Python. So now that it's executed, I want to say Jupyter Lab, and I'm going to go ahead and execute that. And Jupyter Lab, again, like I mentioned, automatically loads the browser window. From there, I have the ability to create a new notebook, and I'm going to use Python to do that. So I'll click the Python icon, and we can see that I'm presented with this block, right? This text block that I can now start adding code. And so for starters, what I'm going to do is I'm actually going to paste in a pretty simple example, again, so you don't have to see me write all this Python code, but we're going to go ahead and step into it and step through it just to see what we're looking at. Now, first things first is that we're actually loading in the MariaDB Python driver, right? That package that allows us to connect to and communicate with MariaDB, in this case, MariaDB SkySQL. From there, I'm adding in connection information like the host address, the port number, the username, password, and I'm specifying the database of travel. I'm then connecting to the database, and I'm establishing a new cursor, which is going to allow me to hold data that I've executed through SQL. And in this SQL statement, we can see that I'm just wanting to look at the count of flights, so everything, the count of the flight table, and I'm just grouping this by year. And I'm doing this specifically from 2015 to 2021, just to add a little bit of spice, add a little bit more filter here. And then I'm just going to be printing these things off. So let's go ahead and execute this code. And we can see that very quickly, I've printed a table kind of formatted here where for every year, 2020 all the way down to 2015, I've just printed out the flight numbers, right? And we can see that for 2020, it's dipped a little bit. And of course, we know why that is for the pandemic. But this information isn't very interesting, right? What we want to do now is I'm going to go ahead and I'm going to paste in another chunk of code here. And this is really going to allow us, as I scroll down here into a new cell that's automatically been created for Jupyter, I'm going to paste this in. Now, here, I'm still importing the driver, but I brought in a couple of the other libraries that I mentioned, such as pandas, which I'm going to use that data frame to be able to hold the data that comes from the MariaDB driver's cursor. And then I'm going to be able to visualize data using Plotly, which is a visualization library available in Python. Everything else here is really the same until we get down, including the query and creating the connection and executing the query, until we get down to this line here where we're creating what's called a data frame, again, from the pandas library. And in there, we're specifying the columns that we want to create that are keyed in on the values that are returned from our query. And then we're simply mapping this into a new bar graph, right, where we've mapped X and Y, X for year, Y for flights, given it a title, and we're going to be creating a simple bar graph using Plotly. So here I'm just going to execute this code, and then we can see very quickly that I've been able to take what we had in just a printed table into an actual bar chart. Now, next, what I want to do, make sure I've got good on time here. Next, what I want to do is I actually want to just change a couple of things inside of this query to create more interesting data, right? So I want to say month, which is another available field within the flights table. I need to add that as a group by, of course, if I'm going to return that. And then I simply want to add that as an order by as well. And then what I want to do is go ahead and add in the month column into my data frame, which is then going to allow me to be able to execute this. Now, last things first is that I actually want to make this a little bit more interesting, and I want to turn this into a line graph. And I can very easily just switch the bar to line here, and then I want to execute. Of course, we can see that I got pretty cool results break down by month here, but what I really want to do is show how I can actually break this data up. Now here we see that I've got different line graphs that signify the different years. So what I want to do is I actually want to break this out a little bit, and I want to add the color coding by year, and I want to switch my x-axis to month. So this allows me in real time just to really change the data, change the way that the data is shown in this case, and show exactly how we're actually able to split this data out. So here we can see that we've got our years, so we're showing the data by year. If we want to, what we can do is that I can very simply be able to display this within the line graph, right? So we're able to see the data here in real time. Now, next, I want to be able to show exactly how we can use something called a map box or a scatter plot. And I'm just going to go ahead and paste this code in here. And we're going to show that, again, we're still using the same packages. We are using the same configuration, but I've changed the query here to be able to join to a different table. It's airports table. And that's going to allow us then to be able to take advantage of things like the latitude and longitude for an airport. And I want to take advantage of this information inside of my data frame and inside of my Plotly graph, or more specifically a map box, because I want to map all this information on top of a map and then to be able to show that in a color-coded fashion. So let's go ahead and just execute to see how fast this query execute and then maps this to a map of the United States. And then if we hover over, we can see we can automatically get information such as the flight count, the latitude, the longitude, to be able to see more information, all in real time, all using columnar storage without indexes. All right. Well, that concludes the demonstration today, but if you'd like to see more information on both columnar storage and how you can use it, as well as more examples using things like Plotly and Pandas, please visit the Developer Hub located at mariadb.com/developers. There you can find samples just like this. You can find tutorials, blog posts, webinars, and dive even deeper. And of course, the easiest way to get started using MariaDB is using MariaDB in the cloud. And you can do so by visiting mariadb.com/skyview. There you can use a $500 credit and you can sign up and get started just within a matter of minutes. And with that, I would like to say, happy coding.